Theta is another one of the Greeks and is a dynamic metric approximating the daily decay of an option's value. As expiration approaches, the value of theta will increase in magnitude at an exponential rate. As you can see in the graphic, the time, or theta, decay starts off slow, and as each month passes, the premium decreases by a larger and larger percent. In the last 30 days until expiration, roughly 70% of the option's value decays. This graphic assumes that implied volatility, IV, and price movement are held constant, which we know is not likely, so that is why theta is an approximation. Buyers and sellers have opposing views of theta. Buyers don't want decay since it decreases the value of the option that they own. Negative theta occurs for long calls, long puts, and long spreads, since the extrinsic value decreases over time. Sellers want decay since it decreases the value of the option that they have sold. Positive theta occurs for short calls, short puts, and short spreads, as in order to realize a profit, sellers must cover their positions and want to pay a lower price to do so. The daily value of theta will oscillate, but as long as we recognize decay when long and utilize decay when short, we will make more sound trades. To note, at-the-money options have the highest theta values, and as options move deeper in the money or out of the money, the theta value decreases. In-the-money options decay most tepidly since they have a lot of intrinsic value and less extrinsic value, so theta decay increases at a slower rate. This is good for buyers and bad for sellers. At-the-money options decay the most rapidly at the end since there is no intrinsic value yet, so the premium mostly consists of extrinsic value. Out-of-the-money options decay more quickly until the end. Theta decays at a faster rate because the option's value is made up of extrinsic value, so as more time passes, it becomes less likely for the option to jump from out of the money to in the money. This is good for sellers and bad for buyers. As mentioned above, the theta decay assumes no change in IV, but we know that this is not the case in reality. As IV increases, the more expensive the options become since they have a greater probability of ending in the money. IV pushes the extrinsic value of the option up, so theta must increase to eat away at the increased time value. In the following graphic, we can see how IV really impacts price, looking at IVs of 25, 54, and 85. We can see that the theta value follows the explanation above, with the at-the-money contract at 45 having the highest theta value regardless of the IV. As IV increases, theta increases for the options, so we need to be aware of IV when we're looking at theta and deciding whether to buy or sell.